everybody. We are back this week for another exciting episode of Adventures in DevOps. And as your only host this week, you have me, Jillian Rowe, and I am joined in the virtual studio by Neatsun Ziv. Hi, Neatsun.
Hey, how are you doing?
I'm good. Good. How are you?
Awesome. So far, so good.
That's great. So, tell the show what brings you here. What do you do? Why are you famous? That kind of thing.
Wow. Okay. Why am I famous? I'll start with something simple. So I'm one of the founders and CEO of OX.Security. We are a company that deals with software supply chain security. And I think that there is a great intersect with DevOps and security. Sometimes it is called DevSecOps. Sometimes it's called scaling platform engineering in terms of security. And I think that we gained a lot of experience that it might be interesting for your listeners to understand what's going on in the industry and how is the security trend going to meet DevOps over the coming years.
Yeah, that's great. So what is going on in the industry and how has kind of the landscape of security changed over the years?
Okay, so if I'm looking on what happened to the broader scope of software supply chain over the past, let's say, 5 to 7 years, we've seen that it became one of the most lucrative attack paths to organization. And the reason for that is that you basically attack once an organization. Let's take an example from SolarWinds. And then you use their mechanism to take the update mechanism of their software, to take your backdoor and actually implement it on hundreds of thousands of different devices that are deployed. So think about a mechanism that somebody already established trust with many organizations, meaning deploying in a secure location, getting the credentials that they need, persistence and so on. You're taking just one company and they're taking your backdoor malicious content and just getting it to all of their customers under a secure and trusted channel. And once the attacker figured out that attack path, it is great way for them to make huge damages simply by taking one target that they need to focus on really hard and from there propagating the attack. So once they figured out, it became more popular to search for more and more of those cases that you can get to one organization and exploit all of its customers and assets. Hope it makes sense so far.
Yeah, it does make sense. I find it really interesting that you use the word supply chain, because I don't think I've ever heard that used in the software context before. You always hear deployment or integration or continuous integration. So when I first heard supply chain, I was thinking like physical supply chain, delivering servers or something like that, but we're in a cloud native world. So I, so pretty quickly clicked onto the fact that by supply chain, you mean, the software going around, right? Not the physical servers.
Yeah, think about it this way. So your software supply chain is, as a vendor that manufactures software, you're relying on others to deliver their software to you. It might be component, open sources, Dockers. It might be pieces of code. It might be a lot of different things that are building your product. And if you look on your bill of material, that you're going to find in that list a lot of external services and packages. Some of the customers that we're working with, you might find there 100,000 items on a list to build the main product. Now think about this, that if you've got such a huge install base and you're relying on hundreds of thousands of components, then this is your actual attack surface. Now, if you think about it, you're building your code with some kind of a CI/CD that is cloud-based. This cloud-based now can be accessed remotely, and you need to think about each one of the components along the way, and how do you think about their security. So this is why the term software supply chain security came into place. It is a composition of many fields that used to exist in the past that are now combining, thinking about everything as chains versus just siloed content in code security or software composition, but thinking on the entire journey of your software from the moment that you design it and ask for suppliers to join in until you deliver it to your customers.
That's really interesting. So let's say, that we are working in open source software and we do have, we do rely upon software that relies upon thousands of other packages, one of which might be, completely broken, or there could be some kind of vulnerability found in one of those. What do you do in a scenario like that?
Okay, so the easy answer is always upgrade. But here comes the challenge. The upgrade comes with some kind of a cost. So if it is a minor version, usually the cost is not that high because usually in a minor upgrade, you don't break interfaces, there are no major changes and so on. But what happens to older packages is that you look right now on packages that are 3 years old and they might have 70 different vulnerabilities. And some of those vulnerabilities require a major upgrade. So in major upgrade, nobody promises that the interfaces won't change. And then you're getting into a more risky place. Saying, okay, if I'm doing a major upgrade, maybe it's a good opportunity for me to actually clean everything and upgrade everything across the way and not just keep one component upgraded. And then people actually get their own protocol of saying, when do you do a major upgrade? When do you do an addressing of minor upgrades? And it becomes a more complicated event that there is no one flavor for. Every organization have their own risk appetite, and by that they decide what they want to do with it. Now, as you mentioned, it might be thousands, and then you need to figure out, okay, what is actually exploitable? What is connected to the internet? What can I actually provide a solution to? And it becomes a very complicated issue of large-scale numbers and multiple options that you can choose between.
That's interesting. So what kind of risk versus benefits, do you typically see people doing? So obviously, the benefit would be if you're always kind of on the bleeding edge, hopefully the hackers haven't gotten to the code base yet, or something along those lines. Maybe you could talk about that with the risk being that, first of all, maybe they've gotten to it anyways, and then also if you're upgrading, there's quite a lot of maintenance and upkeep and that sort of thing. So what do you typically see kind of happening out in the wild with? Do you have clients or you have a product?
So we've got both, but I'll give you an example from I think Log4j is a great example. So Log4j, it was I think almost a year and a half, more than a year and a half ago. But the interesting point about Log4j is that it was actually a known exploit in a package for a long time. But nobody was actually able to say this package is being exploited in the wild. And once a package is being exploited in the wild, then everybody becomes obsessed in let's fix this. Now, if you've got 6 months, then you can plan for it. If you've got 24 hours and there is a directive saying there is an exploit in the wild, we're using that component, we can be vulnerable just like anybody else, then everybody simply scrambles to figure out what is my next move? How can I contribute to this? How can I even find if I've got Log4j in my system? And you get to the point that you're asking yourself, okay, how do I even get started? So if you're looking on the bigger risk management, you should probably ask yourself, first of all, am I impacted? Do you have this package? If so, is it internet facing? Is it an internal issue? Do we have a fix ready for this? Do we need to do a minor change, a major change? How can I verify that everything that I've got already running in production actually is being patched? Because one of the things that we've seen is that many fixed the code, but they did not deploy to production. So they were thinking that they are ready, but realistically the production was still using older versions. So there are so many different pitfalls, and I think one of the things that you really want to do at that point is create a clear plan in advance saying, if something happens, what are the steps that I'm going to take? And this is something that larger organizations, usually organizations that have some kind of incident response or digital forensic practices, understand how to build those programs. The rest simply, what we've seen is hundreds of organizations simply scrabbled through the entire code base, upgrading the version, hopefully hoping that nothing will break as they do it.
Yeah, the wait and see, or have your infrastructure rely on a prayer kind of thing. That tends to be my approach to security, which I, maybe should not be admitting to on there, but here we are. That's okay.
Well, that's a common practice. I think that it can carry you until a certain point. The point that you've got too many assets that are important and they cannot be out there just exposed, is usually when a company reaches about 100 developers. I don't know exactly what happens at 100 developers, but usually around 100 developers, you start seeing a dedicated AppSec team that is looking into the details. And when you've got somebody saying, I own this risk, and they're saying, look, we don't really have any controls in place, then at that point, things start to get accelerated in terms of understanding the risk exposure.
That's interesting, especially, you're talking about it as like kind of a, I suppose not incremental, but you take it sort of, you know, like piece by piece, or say like, okay, you have an upgrade cycle or something like this. Where does, these kind of technologies where you're sort of putting in the security as a part of your CI/CD process? So for example, I use like a lot of containers, and a lot of those containers have, like they're uploaded someplace, and then they immediately get the security scan, and then you can see like, okay, like, how many high, how many low, how many, like so on and so forth. So for example, if you want to put a container into the AWS marketplace, it has to pass like a certain threshold of being secure. Not 100%. You can't actually get it to 100%. I
Never,
don't think.
never,
But there's never. But there's some, there's like some kind of threshold there. So I'm wondering, how do these kind of two, are they different sort of strategies for dealing with security, or are they kind of part and the same, and everybody's just sort of doing the best that you can? Should be, if you care about security, should you be continuously scanning your software? Like what can you do?
So two different questions. Number one is everything today is siloed. This is kind of the problem with the traditional AppSec world. The challenge is that you've got different silos. You need to figure out what are the silos, buy different products in each one of the silos, and then try to understand if you've got a full risk map. This by itself is really tedious work, because you need to understand what's going on in the industry and understand for each item whether you're able to locate it in your system, yes or no. So in order to help with that effort, we've created a map called the OSCA framework, which is the Open Software Supply Chain Attack Reference. It is located in the website called pbom.dev. And the idea behind PBOM, or Pipeline Bill of Material.dev, is to give everybody the visibility on what are the risks that are out there, so you'll be able to understand, first of all, how does the landscape look like? And now that you know everything in the landscape, your next move will be, okay, do I have the right coverage for those? Now, you mentioned Docker. So Docker is one silo, but there are about 12 out of those. And if you're, for example, forgetting a simple password in your Docker and then uploading it to a public repository, then somebody might go through the layers of your Docker, see the password, and again, use that password. And you might say, oh, like, this is really cool as a theoretical question. But in reality, there's a famous case called CodeCov, a simple software that tracks coverage of tests. And they did exactly that. They forgot a password to their CDN as part of their Docker so anybody can download. You can just go over the layers, see the password, go directly to the CDN, because the password is simply embedded in Docker, and change the artifact.
Oh no, did anybody change it?
Yes. Over a million developers got hit by that. It was less than a year ago.
Oh no. I don't even remember that.
Yeah, so this happens.
Yeah, but that's crazy.
So every week there's a new story like this. And it's really hard to educate everybody on this. So I think that this is the time where you're asking yourself, okay, am I going to do it with a pen test once a year? Or am I going to embed this methodology to some kind of a CI/CD? So I ran an organization with about 600 developers before OX.Security. And for me to enforce anything in a 600 developer organization, that became incredibly hard. Everybody got their own priority. It is almost impossible to change all the...
I think I would prefer to herd like kittens and toddlers than 600 developers. You have your work cut out for you with that.
I must say that I enjoyed it really, but yes, enforcing something on developers, that's super hard. And if you're not doing it in near real time, I'll probably say it's near to impossible. Going and asking them to fix something the reason it's impossible is that you have a mental image saying, this is how my organization looked like, 600 developers. And then 3 months afterwards, you're saying, I need to figure out who wrote this piece of code. And everybody changed seat in the meanwhile and changed projects. And now you find somebody and say, can you please fix that? You wrote it 3 months ago. I said, no, I'm not associated with that project anymore. You need to find somebody from that project to do that, because if I'll commit the code, I'm accountable, and you need the new owner to do that. Say, okay, who is the new owner? So I don't know, go to the team leader. But the team leader was promoted, and there's a new team leader in place, but he doesn't know the history. And now you need to, and this is like every story you hear starts like this and ends with, so who is the owner? So we don't really know anymore. So they say to the team leader, can you please figure out who it is and fix it? And say, okay, but I need just to approve the priorities with my manager. It's like, I'm your boss of your boss of your boss. Can you just figure that out? So yeah, let's bring everybody and have a discussion on this. And if you need to manage this in a scale of about 60 different teams, it is near impossible. So definitely, I'm not doing the retroactive mode anymore. That's unmanageable from my perspective.
So that's the retroactive mode. So what would be the reverse of that, or the opposite of the retroactive mode?
Okay, so think about it this way. You've got somebody in your organization that have some kind of a vision saying, this is my security protocol. I know my security protocol, I know what I want to achieve, and we probably already have some kind of a plan implemented. And we've got this platform engineering that all the code is being built from that platform. And now you want to embed that every time that somebody commits code, it goes through some kind of a sanity check saying, does it make sense? Do you embed secrets into the code? Do you build new code on known vulnerable, let's say Docker in this case, and are different silos, and you want to check that everything is there and then communicate back and make sure that everything is user-centric. So you can find a developer that owns the problem right now, today, and help this guy to fix the issue as you speak, not tomorrow, not the day after you commit. If the code is already committed, then the incentive level to go and actually fix it drops to zero. It's like, it's already done, it's already working. I do not want to touch it. Anything that I will do will simply break what I've done before. So it's just about focusing on allowing them just in time to understand what is the issue, how can this be done, and working with their own tools. So many have tried to do plugins to the IDE, for example. But what we've seen is developers saying, I don't want you to change my development infrastructure or experience. Give it to me simple. You want to talk to me with GR tickets. You want to block my pull request, write it down as part of the rejection reason. Don't invent new interfaces, don't invent for me a new case that I can go in and say, now you need to log into another system that I was not enabled on. Simply go and focus on what can work for you.
Yeah, I too like to keep it simple and not have to log into too many places. I get upset when I have clients that expect me just to use their computer. I don't want to do that. I have my computer. It's set up the way that I want it. So I think I'm one of those difficult developers too. But I get it. You have your whole environment and your system, and you don't want to spend brain space figuring out something different.
Yeah, and that's when you think about it, how many IDs are there? And sort of working with organizations, there are a lot of those. So some of them support plugins, some of them do not support plugins. Some of the people that we work with really like to work with just the basic Vim.
Yeah.
Yes. Meaning, I'm not sure it's scalable to anything besides editing small things. I do not scale huge projects using Vim, but we've seen people do it. And then there are no plugins for Vim. Meaning there are certain things, but nothing more than that. So I'm trying to figure out how can we do this, and we just said, let's focus on their code environment, and let's make that simple.
Okay, so do you have plugins and things that you put into the code environment? Are you making plugins for VS Code or Vim, I guess, in this case?
Yeah, but the point is that even though we've released them, I think most of them failed miserably in terms of security. Because the concept of IDE plugins are developers that they need something for themselves and they want to enhance their development experience. And security is usually not on that side. So we hadn't seen huge adoption from that perspective. So definitely I think that the right way to do it is during the CI/CD build, giving notifications, allowing you to understand exactly what's your process, how to build them, and giving strong advice saying, this is how you used it. We would recommend you to use it in this way, which is more secure. Here's the explanation why. And instead of trying to create some distance between security and developers, try to enable them. Because if you do not understand what you've done wrong, then the pushback would be great. And we're trying to say, no, here's the issue, here's what we're trying to avoid, here's what happened before when somebody did that, and here's an easy fix. It doesn't cost you anything to change to a more secure way. Let's please try it this way. And this is the direction.
I like that kind of workflow, especially if specifically, GitHub will not allow me to either, merge my branch or make a push until these issues are fixed, like that kind of thing. Sometimes I need to be forced. I think sometimes people need to be forced into making the decision. Otherwise, I'll take the easy way out and be like, yeah, it's fine, it'll be fine.
Yeah, exactly. And within 3 months, somebody else will replace me on this project, and he'll be fine as well, I hope.
It's a bit of a sink or swim scenario in that case, but we've all been there.
Yeah, so this is what we're trying to address and saying there are better ways to do that. I think that the challenge with the current ecosystem is that it's simply that it is not built that way. The tools are not thinking about the entire software supply chain. They're thinking about, can I create for you the best list possible on all the issues that you can find in your code base on my silo? And when you get those long lists and you get them back to development, a team leader will get the list with the 30 items, and he's seeing those 30 items, and he's saying, oh, each one of them is going to cost me probably a day and a half, maybe 2 days. And he's saying, okay, this is like 3 months just to fix the issue list you've got here. And developers at that point, they're saying, okay, this is actually not connected to the internet. And this is actually not case that is exploitable. And this case, and they come back with the 30 and saying, okay, so what are you going to actually fix from those 30? And saying, after reviewing it internally, there's nothing here worth fixing. What? It's like, there are 3 criticals here. So, yeah, but there is no exploit in the wild for those. So it is not recommended that we will fix them. It's like, okay, but what happened when the moment that somebody will have an exploit in the wild? So yeah, at that moment we'll probably need to fix that. So, but at that moment of time, you will not have time to fix that. And every dialogue sounds exactly like the same way. And then when something happens, say, why didn't you let us know in advance? We would have fixed it when we had time. And this is kind of things we want to avoid.
Round and round you go. Yeah, I mean, security and risk assessment and all these kinds of things are so tricky because you're dealing, there's like known unknowns and unknown unknowns, so you don't know what's gonna, potentially like crop up and what's gonna be the next, big thing to hit. So the best that you can do is sort of make decisions with the incomplete data that you have, because by definition you're never gonna have all the data that you need.
But wait,
so it's always kind of an interesting thing.
No, but think about it again. When you're saying we need to accept the current situation, maybe we do not need to accept it, because let's say that you had somebody, an AppSec person dedicated to go over the list of issues and say, you know what, I'll go over them one by one and I will provide evidence that it is connected to the internet and that there is an exploit in the wild. And I'll go over each one of them and actually do the heavy lifting on each component. And then we think about it saying, okay, if it's internet connected, can I actually automate it? So, yeah, okay. And if there's an exploit in the wild, can I automate it? So, yeah, probably you can do that. And you can go over the questions and figure out, can I ask the right question and get technical proven answer for that question specifically? And as we discovered that the answer is yes for most cases, then you're saying, okay, let's think about a model that answers all the questions. And the way to think about it, is it reachable? Is it exploitable? And what is the damage? So let's take this example of reachable, saying, okay, is there an API that is internet exposed? Yes or no? And let's say that I can get to that API. Is there a route from that API to a vulnerable function or a vulnerable open source? And we know how to do that with technologies like taint analysis. And you ask yourself, okay, is it exploitable? Yes, we've got intelligence saying, is it exploitable? How likely it is to be exploited, and so on. And then what is the damage? We actually know from the code. There are databases, there are APIs, there's access to PII, there's access to authorization system. It's already written. It's just that nobody created the structure to this data saying, can we get it to the template that will be answered to provide evidence to developers saying, why is it important for you to fix this? And doing the triage for you.
I've never heard it stated like that, so I suppose there are fewer unknowns that I was previously thinking. We don't just have to, waltz into the dark and with our hands up being like, well, what do? We don't know what's happening. It sounds like there is data and there is a framework out there. So is that what your company concentrates on, is trying to create this framework of like, okay, we have all this data around security and let's get it into an actual, something that's actually like consumable. We can query it, we can use it to give evidence to developers and companies to do some kind of risk analysis? Like, what happens with that?
Exactly. We're focusing on three pillars, and this is our promises. Saying, first of all, we create for you the best list of issues with everything that we know of in your system that is cross-silo. So instead of thinking about different products that you might own pieces and then trying to build the full list, we'll actually build this list for you. And this is based on the OSCAR framework that makes sure that you've got coverage for the entire ecosystem. The second one is, okay, now that we've got everything, let's do the triage together. And we will provide to you evidence saying, why do we think those are the issues that require your attention? Now, in most of the organization, after you agree to that process of saying, if we've got the evidence and we can sample a few of them and see that they are correct, we can actually reduce about 99% of the noise. Saying those are hygiene problems, they're important, but those are not risk at this moment. And if we can just focus on the risk, that 99% of the noise you can actually throw away and say, we understand. Nobody's going to go back and fix it. We can enforce it on new developments, but nobody's going to go back and close the backlog. Mm-hmm. And now that you know how to do that in a repetitive way, the next thing is to automate this process, saying, I've done this case for 20 times. There is no reason for me to continue in doing it in a manual way. We'll send the Slack automatically. We'll do the PR, the pull request automatically. We'll do the block automatically. We'll do this and this and this. And you can actually build a platform in the engineering component that can allow you to prevent security issues ahead of time.
That's really interesting. So do you have any like really cool success stories, or maybe stories on the other side where somebody should have been listening to you and they didn't, and then they crashed and burned? Because I'm super petty and I always want those stories too.
I'll try not to give those examples. I know that they're the easiest to consume, but I'll try to focus on positive in this call. I think that one of the cases that we had a few weeks back, it's a relatively older client of ours. He's been with us since the design partnership stages, and they recently had an Excel pen test. And the pen test provided to them some answers which were not that favorable. And they waited between the pen test until the pen testers delivered the results. They waited about 2 weeks until they gave them the final report. So while security were doing their thing and going back to developers saying, guys, we found here a few exposures, they came back and said, yeah, it's already been alerted. It's actually already being fixed. If you tell right now the pen test to check it, it's already being fixed. And what happened is that somebody shipped a new API on that day specifically of the pen testing. They were in detect mode. So the system detected it, they got notification, they actually fixed it within a week, and it was closed. But in that period of time, the pen testers actually picked up on that and was able to demonstrate that that was great. It was great. But the point is that from that moment and on, they said we got the confidence to move to prevention mode. So if somebody's trying to push a new code and they're adding a new API that touches PII and databases, and they hadn't done any parameter sanitization, for example, then we want to block it. So on that day, they got a decision saying we're moving into preventative mode instead of just doing the view mode that they were in at the same time. So I think that's a really nice story for us. Another story from last weekend, actually. It's a customer that went through the internet. We didn't talk with them. They found us on the internet, went to our PLG product, tried our product, and then they sent us a mail saying, guys, thank you very much. You just found a dependency confusion in my system. Apparently we had the backdoor. Can you please send us a quote for your system? Which was like, okay, we did not see that coming.
Always happy to send invoices around here.
Yeah, meaning that was like, we never had that somebody says, we tested your product, it was unintentional, we heard about it from another person that is using your system. They tested it, they actually found somebody already that already infected their backend, and they were able to find where it happened in the code, which is like, they did not expect to see that. And at the moment that they saw it, it drove immediate action.
That is a very cool success story. Yeah, I can see why that would be great.
Yeah, and we see those cases quite a lot, not that drastic, but you find quite a lot of those, because think about code base, it's huge. It contains millions of lines of codes. Nobody knows them. They were built layer on top of layer on top of layer for years. And then just finding something that is critical, it's really a common thing from that moment on. You just need to figure out what's the big list, what's important out of it, and how can I prove that one specific issue is more important than others.
How do you prove that one is more important than the others? Like what you were saying earlier, that you can find an exploit in the wild for it, or is there another criteria?
So I'll try to neutralize the three components. So think about it that if you've got something that is exploited in the wild, but you don't have it in your system, that it's not really interesting. If you've got it in your system, but there's nothing in the wild, once again, not that interesting. If you've got it in your system, it's in the wild, but it's an internal system that nobody built for 6 months and it's not deployed, once again, not really interesting. So you actually need to think about it saying, I need it to be with the issue is reachable from the internet, from the relevant API, I can get to the vulnerable function. I need to be able to see that it is right now running in production and that it touches some kind of an interesting asset. Databases, code, PII, secrets inside of it. If there is no combination of all those three, then it's not really interesting. Nothing can be done that can create real damages. And then it's just about proving them step by step. It's doing the heavy lifting of going and checking all the end cases.
Well, do you have any other stories you'd like to share, or you want to move on to the next topic? Well, actually, what is the next one?
I can actually use this as a segue to the next one, which is government-grade attacks. So one of the interesting things that we've seen over the past years is that governments also understood the power of using those kind of attack to attack the software supply chain through the CI/CD, through cases like this. So a few years back, two neighboring countries that are currently fighting with each other had an awkward situation where the bigger one allegedly attacked an accounting or the other countries' counting software, and we're able to inject something into the upgrade mechanism. I think that was like 6 years ago. And when you think about it, that if you're a government that distributes the accounting or the tax software to everybody in your country, and you cannot file your tax reports without that, then everybody must download this software. Everybody. And if you're able to attack that software, you're basically getting into every large company in the country. You're obligating them to download a backdoor. Now, it sounds extreme, but there are so many different cases like this. And this is the interesting part where you can actually scale this and say, you know what, I'm going to do this on a larger scale. And I think it's something that we're seeing constantly. So
That is interesting. I mean, yeah, more and more. I mean, I don't know. I don't even think about downloading software. I remember like when I was a kid and my parents being like, careful about what you download and you're going to put like malware on the computer. And I was like, yeah, whatever. And I guess now we're almost back there. On full
I
circle.
actually have a lot of cases that I kind of ruined my dad's computer like that.
Yeah, I think that might have been it. I might have ruined the computer one too many times by downloading games, and then they decided to put a stop to that. Yeah.
Yeah, exactly. So everybody was infected with something at that time. But yeah, I hope that right now people are using more SaaS services than actually downloading things. So I would say we're better in terms of that security.
As long as the SaaS is okay. That's what I was thinking about earlier, actually, is that right now I'm kind of doing an experiment where I'm trying to say, okay, how much can I do what I do, but using other services I want to do it for like less than $300 a month, right? But like all hosted services, I don't do any of the infrastructure. So it's a bit of an experiment. I have no idea how they handle their security. None whatsoever. So that could be part of the experiment, is to go try to find out how they handle it and how the security is managed, like when I have the different SaaSes and they need to like speak to each other as well, like how all that is handled.
So I can tell you that we're among our customers, we've got quite a lot of SaaS services. I'll probably say that around 200 SaaS services are using our services right now. And I think that you can see their improvement over time as they're starting to use some kind of a methodology to increase their security. And they can actually testify that the process that they go through creates them in a better way, more secure way, that they can't look right now on what they've done 2 years ago. So we don't believe that we hadn't done anything to secure that. Today it seems insane.
That seems like a good way to move forward. Although is there any way to tell like which SaaS products maybe have some kind of security built in, or?
No. So SaaS services, as you can imagine, they're usually priding themselves with certificates like SOC 2. But I've seen somebody post it on LinkedIn recently that 99.9% of the recently disclosed attacks happened on companies that have SOC 2. Now, it kind of makes sense because as a company, you go to a certain level, you need a SOC 2 certificate, and this bar is not that high, meaning once you're 20, 30 employees, you kind of need to get to that point. And there are no interesting cases of break-ins to smaller companies. All of them are to larger companies that have the certificate. But it is still mind-boggling saying 99 point something percent of the cases actually are in places that have SOC 2 in place.
I wonder how much that is a reporting bias, though, because if you're a smaller company, and you don't have those certificates, maybe you don't even know, or maybe your whole system would come down and you would just like rebuild it, or you would just go out of business. You'd be like, all right, I've had enough. I'm gonna go open a hardware store or something like that. Is the one that I seem to hear about a lot. I'm gonna go, live off in the woods or something like that. So maybe, I don't know. I wonder how much is like a reporting or confirmation bias in there as well.
From what we've seen, actually, think about it this way. When a threat actor needs to attack somebody, there are two ways to do that. One is an automatic way, saying, I'm just going to build a bot. This bot will go over the internet, crawl it, and try to do something. But that's really recycling old technologies. if you've got somebody saying, I've got a high value target, HVT, and then I'm trying to attack the target, then usually it's not an automatic process. Somebody needs to manually go over this and especially craft an attack. And if you've got a small organization, 10 developers, usually nobody's going to place the effort on this asset because it's not really interesting. There is nothing interesting in the asset list of that company. So you would go up in the size of the company because you'll be looking for companies that own, let's say, they're already selling a few hundreds of millions of dollars because it's already messy, it's already, there's something to take from them, and then it becomes interesting. So reporting bias, yes. I wouldn't say it's a huge reporting bias. That's my intuition at least.
That's interesting. I mean, the other one that I was wondering about is, is there more of a bias towards, like I suppose, let's say like more commonly used software? So for example, I don't know exactly how WordPress rates, but I know it's one of the most common, like it runs an awful lot of websites on the internet, let's say. I don't remember the percentages. And, and it seems like they're always having like security fixes or I tried to have a WordPress website once and it got hacked, and then there was like a cheap, jewelry store being shown as my business website, and I was very unhappy about that. Mostly because if it was a nice jewelry store, I would have asked for a cut, and then that could have been that. But no, it was a cheap one. So I'm just wondering, like, how much is it? So maybe there's some reporting bias, and then there's also some just having more visibility. So for example, something like WordPress, it's out a lot. If somebody wanted to do something nefarious that could affect, a lot of sites, you could pick WordPress, and then that gets you a big chunk of the internet.
So WordPress by itself, it's a huge system, and the more common the system, the more issues it's going to have. That's kind of the law of the vulnerability disclosure. And you can see, for example, that Microsoft right now, they're fixing every Patch Tuesday, they're fixing a huge number of issues. The systems are so common that they need to do that. And as iPhone and Android got better and more famous, you can see the number of issues being reported to them grew drastically as well. So for them, it's a balance, saying, okay, can we just say the more common it is versus, I would say, how exploited it is. And if Apple wouldn't have raised their level of security year after year, the numbers would have been tremendously higher than what it is right now.
That's interesting. Yeah, it's a good way to think about it. Well, I think I'm all out of questions. Did you have anything else you wanted to discuss?
No, it was fun. Julian, thank you very much. It was a pleasure.
Yeah, thank you. All right, so where can people find you if they want to know more about security or, in general, or your product in particular?
So first of all, getting to hold of me, that is easy through LinkedIn, Neatsun, Neatsun Ziv, Z-I-V, and you can see more about what are we doing and understanding those 3 promises and how do we actually fulfill them and getting to try our product at the website OX.Security. So OX.Security.
Great. All right, well, let's do picks then. So I guess I'll go. It's just the 2 of us, so I'll go first. So I'm going to pick the latest season of The Dragon Prince, which is a show on Netflix. And I think I'm only going to be picking things that I can get both of my kids to like, because it is so hard. It is so hard, you guys, to find something that both of my kids actually like, that we can all, sit down and watch or do or consume or, whatnot together. So that's it. That's my pick for the week. Do you have anything?
So I'll piggyback on that, and I'll go with the Netflix genre as well, and the kids genre on top of that. So I think that my kids really like the Greasy and the Lemmings on Netflix. I'm not sure if you've seen that one.
No, I haven't. I'll keep that in mind though.
Yeah, that's really hilarious.
Yeah.
It's short episodes, 5 minutes, 7 minutes each. It's a bear that just want to sleep and eat, and the lemmings, all they want to do is have a party, have fun, and they somehow always meet each other. And at a certain point, my kids noticed that it's a nice analogy to parents versus kids.
Oh no. That sounds like
And
it could be chaotic.
and once you figure out that, wow, this is actually, if this is an analogy for kids versus parents, you look on this and every episode is super funny.
All right, no, I'll definitely take a look at that. That does sound like fun. Sounds like something good to just have on.
Awesome. Gillian, pleasure.
Oh, it was great. Thank you.
Thank
All
you
right,
very much.
everybody. We'll be back next week. Bye.